An ice cube with mass of 2 kg at 0 degrees C is added to 3 kg of water at 60 degrees C. Assuming that there is no heat loss to the surrounding, find the temperature and the mass of water after the system achieving thermal equilibrium. In this system, the initial temperature of the ice cube is 0 degrees C and the initial temperature of the water is 60 degrees C. Because of the temperature difference, these ice cubes and water, they will exchange the heat. But because the water's temperature is higher than ice cube's temperature, we know that the net heat flow will be happens from water to the ice cube. But if you look at the masses of the ice cube and water, we know one is 2 kg for ice cube and water is 3 kg. So that means their masses actually are comparable. So we can't sure whether the water that provide the heat to the ice cube, the quantity of the heat provided is enough to melt all the ice cube or not. This is a thing that we can't sure. We can check by assuming that the 2 kg of the ice cube at 0 degrees C, due to the absorptions of heat or heat gain by the ice cube, all of it converted into water at 0 degrees C. And the water, the 3 kg water at the initial temperature 60 degrees C, because of the heat loss by the water, and the temperature also will drop until it becomes 0 degrees C. So that means by assuming all the ice cube is completely melted at 0 degrees C, we can take the final temperature of the system as a 0 degrees C. So that means we assume that when the thermal equilibrium of the system achieved at the 0 degrees C. By having that assumptions, now we can check what is the quantity of the heat gained by the ice cube that completely melted to the water at 0 degrees C. So we can use this formula, Qg equal to MILF. Mi is the mass of the ice cube and Lf is a specific latent heat of fusions. So by substituting Mi as the 2 kg and the Lf is 3.36 times 10 to the power 5 joule per kg, we get this answer, which is 6.72 times 10 to the power 5 joule. And the heat loss by the water at initially at 60 degrees C now drop to the temperature of 0 degrees C. So we can find out what is the quantity of the heat loss by the water using this formula MWCW delta T, where the subscript W denotes the water. So the mass of the water is 3 kg and the specific heat capacity of the water is 4,200 joule per kg per Kelvin, and the change of the temperature is 60 because the water's temperature dropped from 60 to 0 degrees C. So we have this value which is 7.56 times 10 to the power 5 joule. Sorry, I forgot to write down the joule. We should write down the all the quantity that we calculated. The value that we calculate should have the unit. So in this case, it is a joule. So now if we compare these two values, we can see that the QL is larger than the QG. The heat loss, quantity of the heat loss by the water is larger than the quantity of heat gained by the water. So what is the meanings of it? What is the conclusions we can get, or what is the informations we can infer by comparing these two values? It means that it implies that the heat contributed by the water is not only can convert completely all the water into all the ice into the water at 0 degrees C, it can also make this water produced by the ice cube to increase the temperature. So that means the final temperature cannot be at 0 degrees C. It would be higher than the 0 degrees C, because these quantities of heat is enough to convert the ice cube into water, and then increase the temperature of the water to certain value which is larger than 0. Now we can modify our assumptions by uh, knowing that the 2 kg of the ice cube initially at 0 degrees C, because of the heat gain, its temperature now is the final temperature of it now would be TF degrees C, which is larger than 0. And 3 kg of water, which is initially at 60 degrees C, because of the heat loss, its temperature will drop to the TF degrees C. Bear in mind that this TF is the temperature of the thermal equilibrium, which is larger than 0. Because based on the uh, checking that we have done just now, we know that the final temperature cannot be 0, and then it must be larger than 0. And then this value should be TF, which is larger than 0. So now we take in our calculation, we will take this TF is larger than 0. In our calculations, we also assumes that the heat gained by the ice cube, the total amount of the heat gained by the ice cube is the same of the total amount of the heat loss by the water, so that we can have this equality sign to equate between the QG and the QL. But now the QG, since we already know that the final temperature of the equilibrium is larger than 0. So now at the left hand side, we have two terms. The first term says that the ice cube completely melted into water, and the water produced will increase the temperature from 0 to the TF. So this CW is the specific heat capacity of the water produced by the ice cube. And the Mi here actually is the mass of the ice, same as this one. But at this term, actually this Mi is referred to the mass of the water which is produced by the ice cube. And at the right hand side, for the heat loss, the formula is equal to MWCW 60 minus TF for the water that due to the heat loss, its temperature dropped from 60 to the TF. Okay, and MW is the mass of the water. CW is also the specific heat capacity of water, which is the same as this one. Now the second term at the left hand side, TF minus 0 can be simplified into the TF only, and the right hand side, the things in the bracket, now we can expand it, so to make sure the right hand side to get the two terms. Okay, since our aims is to find this TF, which is the final temperature after the system achieve the thermal equilibrium, so the next step is that we try to put this second term at the right hand side and the second terms at the left hand side of the equality sign together. So if we bring them together, we can factorize the CW and TF, CW and the TF, and then we write at the left hand side and the right hand side. That means this MI, FI, we have to bring it to the right hand side. So the right hand side, we have two terms also. And now we can write this TF as a subject of the equations by bringing this CW times NI plus MW to the right hand side. So now this TF is a subject of these mathematical expressions. After we have this TF as a subject, it is now the times to substitute a value for all the symbols at the right hand side. So MW is the mass of the water, which is 3 kg. CW, and this CW is 4,200 for the specific heat capacity. Mi is the mass of the ice cube, which is 2 kg. LF is the specific latent heat of the fusion, which is 3.36 times 10 to the power 5. And this Mi plus MW then is 2 plus 3. Now we can get the final temperature of the system after achieving the thermal equilibrium is 4 degrees C. Now, because we know that the ice cube is completely melted to the into the water and increase the temperature to the 4 degrees C, so the mass of the water in the system now will becomes 2 kg plus 3 kg of the original water that we have in the system. So the final answer is 5 kg of the water that we can get in the system.